Good morning, Class 8. This is your chemistry book. I am Sonali, your chemistry teacher for the session. Okay, so we have completed our chapter number 1 in our previous video. We have started chapter number 2 and we are on the process of reading this chapter. Okay, so in the second chapter, physical and chemical changes. The name of the chapter is physical and chemical changes. So in this chapter we have completed the classification of the changes on the various bases. So we discussed about reversible, irreversible changes, then we discussed about periodic and non-periodic changes, desirable and undesirable changes. Okay, then we studied about the examples of physical changes and the examples of chemical changes. Then we studied about what is the energy change involved in those changes. Okay, so the last topic of this chapter is left. Okay, and today we will discuss about the last chapter of this topic. So the last topic is energy requirement for the completion of the change. The energy requirement for the completion of the change. Okay, so just look into your books on page number 14. The energy requirements are different for the completions of the two kinds of changes, endothermic and exothermic. We have discussed about the endothermic changes and the exothermic changes. Okay, what are endothermic changes? In which the energy is absorbed. Okay, the energy is absorbed. Okay, but what are exothermic changes? In which the energy is released. Energy is released. Okay, so you have to memorize these two words, endothermic and exothermic. In endothermic, energy is absorbed, while exothermic, energy is released. Okay, so now we will discuss about what are the energy requirements for the completion of these two kind of changes. So first we will discuss about endothermic changes. Okay, you know that energy is absorbed in an endothermic change. In other words, a substance essentially requires energy from outside to undergo an endothermic change. Okay, so when we discussed about the endothermic changes, we studied that the energy is absorbed in these changes. So when energy is being absorbed, means it is taking energy from somewhere outside. Okay, so for an endothermic change to be happen or to take place, some energy from outside is needed. Okay, hence an endothermic change continues only till the energy is pumped in. Till the time you are supplying energy to the change or to the reaction, okay, till the time you are supplying energy from outside, only till that time endothermic change will take place. For example, a solid melts or a liquid boils only till it is heated. When you heat a solid or when you heat a liquid, only till then the state of the matter changes. And the reaction between nitrogen and oxygen forming nitric oxide, a highly endothermic reaction, takes place only in the presence of an electric spark. A very important reaction is there in which nitrogen reacts with oxygen to form nitric oxide. Okay, nitrogen reacts with oxygen, N2 plus O2 gives 2NO, nitric oxide. Okay, so it is also an highly endothermic reaction. Endothermic means the energy is being absorbed in this. Okay, so this reaction takes place only till the time, okay, when an electric spark is present. As soon as the electric spark vanishes, the energy change will finish. Okay, so the reaction takes place in the sky only when there is lightning. Only when there is lightning in the sky or when there is an electric spark, only till that time this change takes place. Okay, so for an endothermic reaction, the energy is absorbed and some energy from outside is needed, and only till that time energy change will take place when we are supplying the energy from outside. Okay. Next one is your exothermic change. So what happens in an exothermic change? Heat is evolved in the exothermic change. Evolved means release. Okay, so in this type of energy change or in this type of reaction, heat is evolved, energy is evolved, released. So at the first instance, it appears that no energy should be required from outside by the substance undergoing such a change. Okay, when we are saying that the energy is released, means some kind of energy is present within the reaction. We don't want any energy from outside. Okay, it appears to us from that statement. No, but it is wrong. Okay, it is wrong. And actually, there are many exothermic changes, especially the exothermic physical changes, which do not need energy from outside at any stage of the chain. So we are discussing from the statement, we know that for some of the exothermic changes, energy from outside is not needed. Okay, but a common example is condensation vapor or the freezing of liquid. If the vapor is condensed or a liquid is freezed, some energy is released, means it is an exothermic reaction and no outside energy is needed for it. Similarly, when dilute hydrochloric acid is added to a solution of sodium hydroxide, an instant reaction takes place, forming sodium chloride and water, liberating heat. So the second example is, if you are taking dilute hydrochloric acid, that is HCl, and it is added to a solution of sodium hydroxide, that is NaOH, HCl plus NaOH, so it will give you sodium chloride and water. It is an acid plus base reaction, okay? So it will give you sodium chloride and water, okay? And it will liberate heat, it will release heat energy. So energy is released in this process, so it is an exothermic reaction and no outside energy was supplied to it, okay? But however, many exothermic reactions do not take place without being initiated by heating, igniting, illumination and sparking, okay? So for many of the exothermic changes, energy from outside is also needed to start that reaction, okay? So if we are not supplying energy to it, that reaction will not be initiated, will not be started, okay? So some kind of energy from outside by heating or by lightning or by illumination or by sparkling, some kind of energy is needed from outside to finish to start these exothermic reactions, okay? So some examples are given here. First one is, hydrogen does not react with oxygen when the two are only mixed, but reacts explosively when the mixture is kindled or sparkled. This is a highly exothermic reaction, okay? So when we are reacting hydrogen with oxygen, okay, if you have just kept hydrogen and oxygen and mixed together, okay, they will not react with each other. But as soon as you kindle it, as you kindle the mixture or you give a spark to it, okay, then it will react explosively. Hydrogen and oxygen will react explosively to give the products, okay? So it is the highly exothermic reaction. So much of energy is released in this process, but to initiate it, to start this reaction, we need energy from outside, and we give energy to it by kindling it or sparking it. Understood the first example? Okay. Now second one is, a piece of coal, wood or paper, in fact any combustible substance, does not burn unless lighted. But once the substance starts burning, it burns out completely. If you have kept a coal, a piece of coal or wood or paper, okay, if you are not burning it, will any reaction take place? Will any reaction take place? No. If you start burning it, if you give it some, a spark and all, okay? So if you start burning that combustible substance, once lighted, okay, once lighted means we are giving the illumination, we are giving the energy to it, we are supplying the energy to it from outside, but once the substance starts burning, it will continuously burn and it will burn completely, okay? So to initiate this reaction, we need to supply the energy to it, okay? Now third one is the reaction between iron and sulfur forming iron sulfide is an exothermic process, okay? So reaction between iron and sulfur forming iron second sulfide is an exothermic process. When we are reacting iron with sulfur, the product formed will be iron second sulfide, okay, Fe2S. And it is highly exothermic reaction, means heat energy is released in this process. When iron fillings, so there is the experiment which you need to do for this experiment. When iron fillings and sulfur are mixed in the ratio of 7:4, nothing happens. But once the mixture is heated in a hard glass test tube for a short while, it begins to glow, showing that a reaction has started, okay? If you are mixing the iron fillings with sulfur in the ratio of 7:4, if you just mix it, no reaction will take place. But as soon as you heat it in a hard glass test tube, it will start burning, okay? It will show you a glow, okay, a glow, a simple glow, which indicates to us that the reaction has just started. Now you can stop heating. Once we have supplied the energy, we don't need to give it after and after and after, okay? We need to stop it. Okay, but what was happening in endothermic reaction? As soon as we were stopping the energy from outside, the reaction was also stopping. Okay, but in exothermic reaction, we just need to supply energy for starting or initiating the process. Once we have supplied a little bit of energy and the process has started, we can finish up. Okay, we can stop burning it or stop lighting it. Okay, so now you can stop heating, but you will find that the solid continues to glow and the glow spreads throughout the mass. Now the glow will spread throughout the mass, throughout the reaction, and after the glow dies out and the test tube cools down, you will find that a grayish black solid is formed. So what happens in the reaction? When the glow will finish, okay, when it will completely burn or it will completely lighten up, so what will happen? A grayish black solid will be formed, different from the original mixture. So which substance is this? Which compound has been formed? That is iron 2 sulfide. That is Fe2S. So the reaction was Fe plus S gives Fe2S. Okay, so this was the reaction between iron and sulfur to form iron 2 sulfide, which is also an example of exothermic reaction. So thus we can conclude that an exothermic reaction, once initiated, continues and the heat is evolved is more enough to sustain it. So whatever heat energy is evolving from it or it is releasing the heat energy, that energy is enough to keep the process continue. Understood? So these were your examples for exothermic changes, which only starts when the energy from outside is supplied to it. So this was our topic for today. Now we have completed this chapter reading. Okay, the discussion of this chapter is over. I hope you all must have understood the chapter because in our previous videos also we have revised it. Okay, so I hope you must have done that, and the rest of the things we can do now in the exercises. Okay. So I'm just starting the exercises also because only one topic was there for today. Okay, so you can just revise the whole chapter from points to remember on your own. We have completed the discussion of the chapter, so your homework is just to revise points to remember. Main points you can remember from points to remember. Now you will open your page number 16 in your books. Page number 16. From here starts your exercises. Okay, from here starts your exercises. So you need to take a pencil in your hands or if possible a notebook also so that you can write the answers. Okay, so your first exercise is you have to write the short answer questions. So we are discussing the answers, I am explaining it to you, and if you have a pencil and a notebook, you can just start writing the answers. First one is, what are reversible changes? Which of the two, the vaporization of water and the burning of paper, is a reversible change? Okay, so first answer is, what are reversible changes? See, look into this page. This is the page, it is consisting of the answers, okay, answers printout. So you can clearly look into it. A change is said to be reversible when the opposite change can be brought about by reversing the conditions. So when the change is said to be reversible, when we can brought about the change, the original products, just by reversing the conditions. For example, if you are melting a solid into a liquid. If you are changing the solid state into a liquid state by keeping it out of the refrigerator, so what you need to do to freeze it? You will keep it back in the refrigerator and it will freeze. So liquid will change into solid. Okay, so we can reverse it by reversing the conditions. We can get our original products back. So that is your reversible change. And out of the two, vaporization of water and burning of paper. Vaporization of water, we can get the water back, but in burning of paper, can we get the paper back? No. If we can't get back the original products, if we can't reverse the conditions, that is not a reversible change. Okay. So out of these two, vaporization of water is reversible change. Understood, everyone? Now second, what are irreversible changes? And which of the two, the melting of ice and the growth of a plant, an irreversible change? Okay, so what are irreversible changes? Just the opposite of reversible. And a change is said to be irreversible when the opposite change cannot be brought about by reversing the conditions. If we are reversing the conditions but we cannot get back the original products, or we cannot get back the reaction, opposite change, okay, so that is irreversible. You can just think about from the word only, irreversible. Irreversible means the change cannot be reversed, or the opposite change cannot be brought about by reversing the conditions. So out of these two, melting of ice and growth of a plant, in melting of ice, you can reverse the product, you can again change it into ice, okay? But in growth of a plant, if the plant has grown up, can you get that little plant back? No. Okay, once a thing has grown up, a living thing has grown up, we cannot get back. If you are grown up, okay, can you get back your childhood? No. Okay, so any growth cannot be get back. Okay, cannot be reversed. So they are irreversible changes. The answer is growth of a plant. Next is define a periodic change. Is rusting a periodic change? So what about the periodic changes? Periodic changes are those which takes place at fixed intervals of time. Okay, so periodic changes, what are periodic changes? They take place at fixed intervals of time. You must have seen a simple pendulum. What happens in a simple pendulum? If you will take it from the center to the last position, to the extreme position, and you will leave it. So first it will go from here to here, then it will come back, then it will go from here to here, then it will come back. Means it is following a fixed interval of time. So periodic changes are those changes which takes place at fixed intervals of time. Okay, so rusting. Is there any fixed interval for rusting? No, rusting can take place at any time, anywhere. Okay, so rusting doesn't have a fixed interval of time. Okay, so rusting is not a periodic change, but it is a non-periodic change because it is not taking place at fixed intervals of time. Next one is define a non-periodic change. Is the swinging of a pendulum a non-periodic change? So now we will discuss about non-periodic change. Just the opposite of the previous answer. Non-periodic changes are those which do not take place at fixed intervals of time. Swinging of a pendulum is not a non-periodic change, but it is a periodic change. So we have just discussed non-periodic changes do not take place at fixed intervals of time, and we discussed about the swinging of a pendulum. So because it is taking place at fixed intervals of time, so it is not a non-periodic. Instead, it is a periodic change. Okay, so the answer is no. Now your next question, question number 5 is classify the following into desirable and undesirable changes. You have to classify it as desirable and undesirable. First one, A part is spoilage of food. So spoilage of food. Do you desire the food to be spoiled? No? Okay, nobody desires it. So spoiling of food is an undesirable change. You will make the columns as desirable and undesirable, and you will write in front of that. Okay, the examples. Now B part is digestion of food. Digestion of food. Everyone wants the food to be digested. Okay, so yes, it is a desirable change. You will write it under the column of desirable change. C part, rotting of an egg. Does anybody want the egg to be rotten, or you want to eat it? Yes, you want to eat it, you don't want the egg to be rotten, so it is not desired by everyone. Okay, by anyone. Okay, so it is an undesirable change. Now D is the decay of a dead animal in open air. Okay, so the dead animals, they will decay. Okay, and it is a desirable change because if they will decay, the soil will get the fertilizers and all. Okay, so if the dead animal is decaying in an open air, it is a natural process. Okay, so it is a desirable change. Desirable change. So in desirable changes, you will write digestion of food and decay of dead animal in open air. And in undesirable changes, you will write spoiling of food and rotting of an egg. Now your sixth question is define a physical change, and you have to tell is rusting a physical change. So for physical change, we have just discussed about the physical changes. A change in which no new substance are formed and which can be reversed by reversing the conditions is called a physical change. You just have to memorize 2 points. If any one of the point is missed, you will not get the marks. So you have to write both the points in the answer of physical change. A change in which no new substance is formed. Okay, no new substance is being formed in this process, and you can reverse the reaction by reversing the conditions. You can reverse the change. If it is reversible and no new substance is being formed, then now is rusting a physical change? So rusting is a physical change. New substance is being formed in it and you cannot reverse the reaction. So no, rusting is not a physical change, but it is a chemical change. Okay, now seventh one is define a chemical change, and you have to tell, is the heating of an electric iron a chemical change? So chemical change, a change in which new substance are formed and which cannot be reversed by reversing the conditions. So opposite of physical change, okay, in which a new substance is being formed. If you are burning a paper, ash is formed, okay, so a new substance is being formed and you cannot reverse back the reaction. These 2 points you have to write for chemical changes. Okay, now heating of an electric iron, you heat an electric iron, and when you switch it off, okay, or when you take out the plug, after some time it will come back to its normal form. Okay, it will cool down. Okay, so you can change it, you can reverse the reaction by changing the opposite conditions, by reversing the conditions. Okay, and no new substance is being formed in this. So heating of electric iron is not a chemical change, instead it is a physical change. Understood? Okay, now comes your last question for second last question, 8th for today. You have to classify the following into physical and chemical changes. So I'm just telling you the answers. The melting of ice. The melting of ice, it is a physical change. You have to make columns like this. Physical changes and chemical changes, and you have to classify this. Okay, so in physical changes, what answers you will write? Melting of ice, evaporation of a liquid, dissolving of a solid, condensation of water vapor, sublimation of iodine, freezing of water, glowing of bulb. In all these changes, you can see that no new substance is being formed and you can reverse back the reactions. They are reversible. So these all are physical changes. Now come to the column of chemical changes. This is for your question number 8. Okay, you have to make it the columns. Now in chemical changes, cooking of food, curdling of milk, respiration, fermentation, burning of coal, photosynthesis in green plants, and digestion of food. So these all are your chemical changes. You should know how to classify them. Okay, in chemical changes, in all these changes, new substances are being formed and you cannot reverse the reaction. So they are irreversible. Okay, so in both changes, you have to write it in column form, physical changes and chemical changes for your question number 8. Understood? Now last question is define exothermic and endothermic changes. Okay, so in exothermic changes, a change during which heat is evolved. It is an exothermic change. It's called an exothermic change. And a change during which heat is absorbed. When you are taking in the energy, absorbed. So it is called an endothermic change. Understood? So these were your short answers. We have completed the revision of the chapter, an important topic, and we have started doing the exercises in this video. Okay, we have completed our short answers. You should note down in your notebooks. Okay, now in our next video, we will discuss the long answers and the exercises, remaining exercises. Okay, so till that time, just complete your work, revise your chapter, and please attend your online classes. Thank you.